Okay, so this section 1.5b, again, we're talking about absolute value, this time with inequalities instead of equations. Now, it's actually quite similar to the equations. We're still going to set up two. Here's the difference. When you set up your two equations, you're still going to have the 2x plus 3, the stuff inside the absolute value in both of your two. Again, it's going to be inequalities instead of equations. I'm going to leave these signs for a second. You're going to have 8 in one of them. You're going to have negative 8 in the other. Pretty much what we did with the equations. Now here's the difference. On the one that has the positive, you're going to leave the greater than or equal to. On the one with the negative, it's like you're dividing by a negative. You switch that inequality sign. Okay, so I'm going to go through and solve both of these. I'm going to do this pretty quickly. So I have 2x is greater than or equal to 5. Divide by the 2. I think that it's probably a pretty good idea here to write it as a mixed number because we're going to graph these in a second. Okay, same thing. Divide by the 2. So negative 5.5. And then I'm going to graph these things on a number line. Now I'm fine with a messy number line. I might put one that's multiple choice or something so you know, make sure you could pick it out. But I'm going to put my values on here. Okay, now looking at my first one here at 2.5, it's greater than or equal to, so closed in circle and greater than. Okay, here at negative 5.5, again it has the equal to, so closed in circle. And it's less than, so I'm going to shade that here. Now, one reason that I need to graph it, well, first of all, they're going to ask you to. Second of all, is I need to decide if I'm talking about an and situation or an or situation. You're talking about generally whether it's and or. Now here, they're pointed opposite directions. That's generally the or situation. If it's and, they're generally facing and overlapping. Okay, so let's look at a couple more of these. So here's our next one. I'm going to set up my two inequalities. So 1 minus 2x is in each of them. 5's in this one, negative 5's here. On the positive 5, keep that sign. The other one, I switch it. And then I'm going to solve. So I have negative 2x is less than or equal to 4. Now remember, when you divide by the negative, make sure you switch that inequality sign. Okay, I'm going to do the same type of thing over here. So I have negative 2x is greater than or equal to negative 6. And I'm dividing by a negative, so make sure you remember to switch that inequality sign. Okay, now let's graph this and see if we've got an and or an or to put between these. Alright, so there's negative 2, there's 3. So negative 2 is greater than or equal to. I'm going to shade a little bit so I remember that. Here, it's less than or equal to. Now see how they are overlapping right here? That overlap is your and situation. So here's my answer. They might ask you to graph it as well, which we have. Kind of a messy graph, but it's a graph. Okay, now here, that then is our general situation. Let's just look at a few more that have kind of weird situations in them. Make sure we're good to go. Okay, now you may have an extra number out there. Make sure before you set up your equations, you get that absolute value by itself on one side of the equal sign or inequality sign. So I have 3x minus 6, and absolute value is less than 12. And then I'll set up my two inequalities. And this one, switch that sign and make it negative 12. Then I'm going to solve these. So 3x is less than 18. X is less than 6. So 3x is greater than negative 6, x is greater than negative 2. And let's decide if it's an and or an or. All right, so there's negative 2, there's 6. So with the 6, its x is less than 6. So I'm going to shade that way. Here, it's there, so we have the overlapping, which means it's an and. Now remember, the or would look something like this, and then they're going opposite directions. So ands where they overlap, ors where they're going separate directions. Okay? Another kind of weird one with some extra stuff. Remember, before you set up your two inequalities, you need to get rid of those two things. So I'm going to add my 3. So I have 1/9. The absolute value is greater than or equal to 5. And then I'm going to multiply by 9. I think it'll be the easiest way. Multiply by their reciprocal to get rid of that 1/9. And then I can set up my two inequalities. Switch the sign, and switch the sign, and then go through and solve. So 5x is greater than or equal to 48. When I divide by my 5, x is greater than or equal to, let's see, 9 3/5. Same type of thing here. So 5x is less than or equal to negative 42. Divide by that 5. Now same thing, you're going to want this to be as a mixed number so that you will be able to go through and know where to kind of graph it, especially if I were to give you a number line and you need to know kind of between which two digits it is or whatever. It's a good idea to have it written as a mixed number if you're going to graph it in any way. Now here we're just doing a messy graph. Okay, so the 9 3/4, it's greater than or equal to, and the 8 2/3, or 2/5, which would be a good thing if I had the right number, is less than or equal to. Now looking at that, they're going the opposite directions, which is our or situation. Okay, so I want us to look at one that has a messy situation, kind of a weird situation I want to make sure that you've thought about, and then we'll look at one more. Alright, now I've got that negative 2 that's in the way. I'm not supposed to have it when I set up my two inequalities, so I'm going to divide by that negative 2. Now, two things to remember. First of all, when you divide by a negative, you've got to switch that inequality. The other thing I want you to think about is we've never had those negatives on the inequalities. Remember, on the equal sign, we had these and it was like no solution, it's not possible. Now, it might be possible here, so I want us to think about this. So if I'm talking about the absolute value of x plus 4, I don't know what x is, but I do know that this number has to be positive. Because when I take the absolute value of anything, it's going to be positive. So if I'm talking about some positive number being greater than negative 11, that's true all the time, right? A positive number is always going to be greater than negative 11. Now you need to think about these and see if it's going to be true or if it's going to be false. This one's true, which means my answer is all real numbers. If this was not true, say this was a less than there, then it would be, you wouldn't have an answer, so it would be no solution. Alright, so let's go through then, and let's look at this last one. Now I've got some extra stuff here. I've got the 4 and I've got the negative 7. So I need to get rid of those. before I do anything else. So for absolute value of 2w plus 3 is less than or equal to 16, divide by the 4. Okay, now I'm ready to set up my two inequalities then. So I have 2w plus 3 is less than or equal to 4, as is. And then with the negative 4, switch that sign. And then I've got two things to solve here, which I'm going to do quickly. Okay, so here are my answers. I just need to do my number line to decide if it's an and or an or. I'm going to put the numbers above this time since I don't really have room below. Okay, so with the 1/2, it's less than or equal to, so I'd be shading there. With the w is greater than or equal to negative 3.5, it's greater than or equal to, so I'm talking about the and situation. Alright, so that then is section 1.5b.